1G. The story of mobile networks begins not with apps or internet, but with a single simple idea: making a phone call without being connected to a wall. The world's first commercial mobile network launched in Japan in 1979, and for the first time, people could carry a phone and make calls while moving from place to place. The United States followed in 1983 with its own network, and the device that became the face of this era was the Motorola Dynatac, a large, heavy handset that cost the equivalent of tens of thousands of dollars in today's money and offered barely 30 minutes of talk time before the battery died. The technology behind 1G was entirely analog, meaning voice was transmitted as raw radio waves with no encryption and no data capability whatsoever. There was no texting, no internet, and no privacy. Anyone with the right radio equipment could listen to a conversation in progress. The one genuinely lasting contribution of 1G was the cellular network concept itself, where cities were divided into overlapping zones that allowed frequencies to be reused and more people to stay connected simultaneously. That foundational idea still sits at the core of every mobile network operating today. 2G. The shift from 1G to 2G was not just a technical upgrade. It changed what a mobile phone actually meant to people. The first 2G network went live in Finland in 1991, and the move from analog to digital transmission immediately solved several of the most serious problems of the previous generation. Calls became encrypted, meaning private conversations stayed private. The network could support significantly more users at once, which reduced the frustrating experience of picking up a phone only to find the network too busy to connect. The change that nobody anticipated having the cultural impact it eventually did was SMS text messaging. The first text was sent in December 1992 and carried the words "Merry Christmas," a message so unremarkable that almost no one recognized what it represented. Within a few years, texting had become one of the defining communication habits of an entire generation, with its own abbreviated language born out of the need to say more with fewer characters. Phones shrank from large bricks into compact, pocket-friendly devices, and models like the Nokia 3310 became cultural objects as much as communication tools. 3G. Mobile internet existed before 3G, but it was barely recognizable as such. The first commercial 3G network launched in Japan in 2001, and what it offered was something genuinely new: the ability to browse real websites, send emails with attachments, and begin experiencing the internet on a handheld device in a meaningful way. Early speeds were modest by any modern measure, but later upgrades pushed performance high enough to make the next development possible. The smartphone arrived during the 3G era, and the timing was not coincidental. The original iPhone launched in 2007, followed by the first Android devices in 2008. And neither would have made practical sense without a network fast enough to support them. An app store full of connected applications is only useful if the connection can actually deliver what those applications need. 3G provided that foundation. It was imperfect, coverage was inconsistent, battery life suffered considerably, and video calls were technically possible but rarely pleasant. But it established the pattern of using a phone for far more than calling and texting, a pattern that has only deepened with every generation since. 4G. If 3G made mobile internet possible, 4G made it genuinely enjoyable. The first 4G LTE networks launched in Stockholm and Oslo in December 2009, and the speed difference compared to what came before was immediately apparent. Real-world download speeds between 20 and 50 megabits per second meant that high-definition video streamed smoothly, apps loaded without frustration, and the experience of using the internet on a phone finally felt comparable to using it on a computer. Voice calls moved onto the same data network as everything else, replacing the older circuit switch system that had been in place since mobile telephony began. This was the era when smartphones became genuinely central to daily life, rather than just useful additions to it. Social media platforms grew into mass phenomena, ride-hailing and food delivery services became viable businesses, and mobile gaming expanded into a major industry, all running on 4G networks. Latency dropped to around 30 to 50 milliseconds, which made real-time applications feel responsive in a way that earlier networks could not support. The phones themselves grew more capable with each year, and the competition between manufacturers to deliver the best 4G experience pushed hardware development at a pace the industry had rarely seen before. 5G. The arrival of 5G was announced with considerable expectation, and the technology behind it justified that attention, even if the everyday experience of using it arrived more gradually than many anticipated. South Korea became the first country to launch commercial 5G networks in April 2019, with American carriers following within days. The standard comes in two distinct forms that behave quite differently in practice. The version most people actually encounter runs below 6 GHz, penetrates buildings reasonably well, and delivers speeds between 100 and 400 megabits per second, a meaningful improvement over 4G but not a dramatic change for typical daily use. The second form, known as millimeter wave, operates at much higher frequencies and can reach speeds of 1 to 2 gigabits per second under the right conditions. But its range is extremely short, and solid objects block it easily, limiting it to specific locations like stadiums, airports, and dense city centers. The more significant change with 5G is latency, which dropped to between 1 and 10 milliseconds. That reduction matters less for scrolling through a social feed, and considerably more for applications that require near-instant response. Remote industrial systems, connected vehicles, and augmented reality among them. The full impact of 5G is still unfolding, with much of its promise tied to infrastructure and applications that are still being built. 6G. No commercial 6G network exists yet, and the technology is not expected to reach consumers until the early 2030s at the earliest. What researchers and major technology companies are working toward, however, suggests a generation that moves well beyond incremental improvement. Theoretical speeds in development discussions reach figures that would have seemed entirely unrealistic just a decade ago, up to 1 terabit per second under ideal conditions, with realistic speeds still representing a substantial leap beyond what 5G can currently deliver. Latency targets are below 1 millisecond, which would make the network response essentially imperceptible to human senses. The applications being designed around 6G extend into areas that current networks cannot support at all. Holographic communication that creates a genuine sense of physical presence across distance, real-time digital replicas of physical environments, and connectivity dense enough to support enormous numbers of devices in a small area simultaneously. Whether the devices used to access 6G will resemble today's smartphones is an open question. The flexible and foldable display technologies already appearing in current devices suggest that the familiar rectangular glass form that has defined personal technology for nearly 2 decades may look quite different by the time 6G becomes the standard most people use daily. Which of these generations did you grow up with? And which one are you using right now? Let us know in the comments and tell us which country you are watching from.